Okay, so let's have a look a bit of position of two circles. Okay, basically means if I give you two circles, it can be in many ways. It can either be something like this, or it can be something like this, or it can be something like this, or it can be something like this, or maybe it can just simply be something like this. There are many ways, and I know it's not a perfect circle over there, sorry about it. Okay, what I can summarize from here is this. I mean, come on, please don't laugh too much at me. When I give you position of two circles, it's either they touch or they do not touch. Or maybe they cut. Understand? And when they touch, it can mean externally. They touch are external. Or maybe they touch internally. One of them is inside. Or you can see here they touch they do not touch externally where they are outside of each other. Or maybe they did not touch when it's inside. Or maybe they simply seems like that. Are you okay? So how are we going to memorize it, sir? Well, there are many ways. Here I'm giving you the formula. This one here is when C1 and C2 equals to R1 plus R2. Okay, disclaimer, this C1 and C2 here, it means distance between this center and that center, C1 and C2. Basically, this distance here is the same as R1 here plus R2 there. Can you see it? R1 plus R2 is the same as that distance. Okay, I'm giving you the summary. For something like here, the ideas are all the same. C1 and C2 is equals to R1 minus R2 modulus. And this one here, C1, C2 is bigger than R1 plus R2. This one is quite obvious because C1 and C2 here is longer than R1 and R2. Okay, the distance between the center is bigger than the distance of the two radius. And then this one here, C1, C2 is smaller than R1, R2 modulus. And this one here is slightly confusing, but I haven't seen this one in exams yet. Or maybe I forgot right now. Oh. I think I changed this one. I don't like it. C1, C2 is bigger than R1 minus R2. Okay, so remember when I said position of circle, let me go a bit down. You can have all these 5 positions of them. This one is obvious, this one is obvious. You don't have to memorize it. I mean, you can know intuitively. This one you sort of need to calculate and figure it out. And this one here is slightly a bit confused. So how to memorize? Well, these two is intuitive. I don't memorize them, I just know them. This one here, if it's internal, it's equal. If it don't touch, it's less. And if it's cut, it's more. I think these three is quite easy for you to memorize them. And it's not that difficult as well to memorize this. You can see equal, more, less, equal, less, more. I suggest you study them before you enter exams. Alright? Should we go over examples? Okay, I forgot one thing. How do you find this distance between two centers? For C1 and C2, distance between 2 points. I mean, you can say this one is distance between two centers, but it's basically just distance between 2 points. Do you remember the formula from your school days? Quick. y2 minus y1 squared plus x2 minus x1 squared square root. Basically, how I memorize it is x1, y1, let's call here x2, y2. What happened is just Pythagoras formula. Distance here x2 minus x1. Distance here is y2 minus y1. Then it's the Pythagoras formula. Alright. Okay, we almost ran out of time, so I better be a little bit quick. Can I continue? Come on, Pythagoras. You don't need to refresh that one too much. I'll be a bit speed up here. So if I give you these two circles, and the question can say that find the radius, or radii here, radius I guess. Find the radius and center. And then the question say that show these two circles do not touch. Are you okay? So we want to prove them either this or this. Alright, so let's give it a shot. Sorry, our time's almost run out, so I'll be quick. How do you find the center? Let's find the easy one. How do you find the center of them? The first one, the center is 5s minus 9. Can you see that? Wow, that's fast. How? 2g, 2f. Yeah, this one, see? So 2g and 2f here, so the center is h and k is 5 and minus 9. What about this one? What's the center? We don't have x only, x1. So 0 and 3. Am I too fast there? If I'm too fast, please raise your hand. Right. Now this one here is C. How do you find the radius? There are 3 formulas as I mentioned for you how do you find radius just now, last time. You can either use C equals to a squared plus k squared minus r squared, or r minus r squared, or r squared equals to h squared plus k squared minus c, or my advice is memorize only one. Which one you going to choose? I memorized the first one, I just derived the others two. Okay, so I'm running out of time, so you just substitute in for you to get the radius. I'll say the answer for radius here. The radius for B1 is, one moment, radius for B1 is 6, radius for B2 is 4. Are you okay? So let's summarize a little bit there. So the center C1 is 5, -9. R1 is 6. C2 is 0 and 3. R2 is 4. Alright. So from this information right now, we are trying to show that the circle do not touch each other. Let me remind you again. So either we want to prove this one, or either we want to prove this one. Are you okay with that? Now let's find the distance between these two centers. How? I mentioned you just now. We use Pythagoras theorem over here. So -9 -3 -12 squared 122 144. Well, we got 12, 5 should be 13. So C1, C2 is 13. So now let's have a look. 6 plus 4. R1 plus R2. We got 10. So 13 is more than 10, right? So we got right now C1 and C2 is bigger than R1 plus R2. Sorry about that. 13 is bigger than 10. So which one do we get? We got this one here. Thus, once you reach here, you need to come up with the conclusion. Circle do not touch each other. The circles okay, that's all for today. This is one of the easy examples. I can see that the exam is harder than this. Alright, that's all for today. Thank you very much for listening. Please comment, share, like, and subscribe the video. Yeah, please get a better circle.